Section 5.3 deals with the fundamental theorem of calculus and the definite integral. What we're going to do is we're going to take a look at not the indefinite integral that we have examined in the last two sections, but now the definite integral. So the definite integral, come down here, it looks like this one here. Now the difference is there's limits on this integral. So for an indefinite integral, we were doing things like this, right? We would integrate f of x dx, and we would get some antiderivative, right? We called it capital F, but we'd get a plus c, and the plus c could be any, that c could be any real number, and if it's any real number, then it's indefinite, right? Because we don't definitely know what value it is. Now a definite integral is going to be this. It's going to be the integral from a lower limit of a to an upper limit of b of f of x dx. And the way we're going to get this, by the fundamental theorem, we're actually going to get a value. We're going to take the antiderivative evaluated at b, subtract the antiderivative evaluated at a. We'll show some examples. So first of all, here's what this fundamental theorem of calculus says. If you integrate a function from one lower limit to an upper limit, you get an antiderivative, and you evaluate it from a to b, and you evaluate it first to b, and then you put in and then minus, and then put in an a. Probably doesn't make any sense until we actually do one. Let's do that now. So, for example, let's try this one right here. So we've got limits on it, right? We're going from a lower limit of 2 to an upper limit of 5. And first of all, let's get an antiderivative. So an antiderivative, let's just find the integral of 2x minus 1. So this is going to give us 2, and then x squared over 2 minus 1x. We're going to evaluate this from 2 to 5. But we can simplify a little bit here, right? So we're going to evaluate this, x squared minus x, from x equals 2 to x equals 5. Now the fundamental theorem says we put in the top number first and then the bottom number. So the upper limit is 5, so we'll get 5 squared minus 5, minus, now put in the lower limit, we'll get 2 squared minus 2. So right here, what do we get? 25 minus 5 is a 20, minus 4 squared, 2 squared is 4, minus 2 is 2, so we end up with 18. So what we're saying now is that if we evaluate this integral from 2 to 5, what do we get here? 2x minus 1 dx, the value of that integral is 18.